Every time you touch your phone screen, it knows where you've touched it. But how? This is day 113 of teaching you something new about electronics every day until you become a master. Phones and most modern touchscreens, for that matter, operate on something called capacitive touch, which is extremely simple. Let's take a look at a single cell. In a single cell scenario, we have an MCU and we have a pad. The MCU sends a signal down that pad, which is an alternating current signal. It then measures the current that is required to reach the peaks and the troughs. Typically, the capacitance for the pad is known, so this is a fairly constant value. However, when we bring a finger into the mix, wow, that is a badly drawn finger, it adds capacitance to our circuit, so the current required to reach these points increases. In this diagram, we have our MCU connected to a resistor and then a capacitor connected to ground. This capacitor, which is 1 nanofarad, will take 500 nanoamps to charge in 10 milliseconds. However, if we were to double that capacitance to 2 nanofarads, say by touching the button, we would then have 1000 nanoamps of current to charge it in the same time. This means that there are two ways we can measure this, either by using a constant current, which will increase the time it takes to charge the capacitor, or by using a constant voltage, which will increase the amount of current required to charge the capacitor. However, mobile phones, of course, that would be too simple. So we have two types of lines and rows in our mobile phone. We have our columns, which use the same technology or a similar technology. We then have rows, which are on a different layer, and these measure the change in capacitance by the change in the electric field. So if we were to touch here, that would increase the capacitance on this row, and it would change the magnetic field on this row, so we would know where it had been touched.